Hello everyone, my name is Shreyas. I am an educator at an academy. You can follow me on the Learning app as well. You can see my new set of courses on the Learning app as well. So today I'll be dealing with a lesson, namely the classification of engines, turbines and pumps. So for everything to be discreted properly or segregated properly, we need something called as classification. If there is a detailed classification only, we can actually know the uses of these things. So this is my lesson. So please do rate it, review it and recommend it. And please do subscribe us on our YouTube channel. Welcome back guys for the course Elements of Mechanical Engineering. So let's move on. I've already given my introduction, so you can find me at this Unacademy user platform mentioned over here. You can follow me over there for the new set of courses I'll be uploading in this platform. So the course we'll be dealing with is named as Turbines, Engines and Pumps. So the target audience for this course or for this lesson will be engineering students, general audience who are interested in mechanical entities, people who are interested in machine related mechanisms, and automobile enthusiasts. So the learning outcomes after this lesson or after this presentation will be, you guys will come to know the main definitions or the fundamental definitions of turbines, engines and pumps, the classification of turbines according to the engineering curriculum, the classification of engines as well as the classification of pumps. So let's start with the lesson, classification of engines, turbines and pumps. So let's have a quote before the starting of our lesson. Science is the systematic classification of experience. So as said in the intro video, you can actually see if anything has to be systematically described or systematically organized, then there is a need of classification. So the best example for this is a library. You can see in a library the books are classified according to the properly, so the readers can search for their required books properly. So that's the reason we require classification a lot in our life. So let's move on with the lesson. So turbine, so before going to that, what is turbine? So turbine, it is derived from the word turbulence. So turbulence means nothing but rotating. So turbine is basically a rotatory or rotary mechanical device. So turbine, it is actually a rotary mechanical device that is used for the extraction of energy from a fluid flow and it converts it into useful work. So if a fluid it is flowing on a turbine, so on the rotatory vanes, that fluid when it flows, the force of the fluid is converted into useful work. So it is actually extraction of energy from water or any fluid. So the work produced by a turbine can be used for generating electric power, and when combined with a generator it can also produce thrust. A turbine is a turbo machine with at least one moving part called a rotor assembly, which is a shaft or drum with blades attached. The moving fluid, it actually acts on the blades so that they move and they impart rotational energy to the rotor. So you can see here, these are the blades of the turbine which I was talking about. So the fluids, they hit this rotary blades. So when these blades are rotating, when the fluids hit, you can assume the force there. So that force is actually converted by the use of this connecting rod or the crankshaft. By the use of this connecting rod and the impeller motors, it is converted into energy. So let's move on with engine. A machine which is designed to convert one form of energy into mechanical energy is known as engine. The burning of fuel, okay, so in the engine, the fuel is burnt to create heat, which is then used to do work. It does this by bringing a working substance from a higher state temperature to a lower state temperature. A heat source which generates energy which it brings the working substance back to a high temperature state. The working substance generates work in the working body of the engine while transferring heat to the colder sink until it reaches a low temperature state. So this is what the transfer of heat which is done by the usage of an engine. So you can see here the image of an engine. So you can see here the fuel is actually put over here, the fuel is pumped over here. So that's how the whole engine works. You can see the blades also, you can see the rotational movements also. So when the fuel is put here, these things actually rotate, and that is how the bike or the locomotive mechanisms move. So let's move on with pump. Pump, it is a device that moves fluids by mechanical action. They operate by reciprocating or rotary mechanism, and they consume energy to perform mechanical work by the moving of fluid. They operate through many energy resources including manual operation, electricity, engines or wind power. They help out in a wide range of applications such as pumping water from wells, fuel injection, pumping oil, and in artificial heart and sterile processes. The mechanical pumps, they can be submerged in the fluid they are pumping, or they can be placed external to the fluid. So this is the image depicting the pump. So let's move on to the classification of turbines. According to the usage of energy, the turbines, they are divided into two types, namely the impulse turbine and the reaction turbine. In impulse turbine, they use the impulse force, and in the reaction turbine, it makes use of the reaction force. Then according to the direction of water flow, the turbine is divided into the following, that is axial flow. Axial flow is the flow in which the water flows in a direction parallel to the turbine. So the example for this will be Kaplan turbine. Then coming to the radial flow, in which the water flows in a direction perpendicular to the axis of the turbine, that is the Francis turbine. Tangential flow, in which the water flows in tangential direction with respect to the position of blades of the rotor, that is nothing but the Pelton turbine. Then you have something called as the centrifugal flow, that is the flow which reaves the impeller or the rotor blades radially. They both are similar to the centrifugal flow, but the centrifugal flow, they have centrifugal force, and a radial flow, it doesn't have the centrifugal force. So don't get confused with that. And then we have the last one called the mixed flow. The mixed flow is a combination of all the above said flows. So the example for this will be the Francis turbine, because the fluid, it enters radially but it leaves axially. So let's talk about impulse turbine. Impulse turbine is a turbine in which the flow takes place in tangential direction. In impulse turbine, the hydraulic energy of the fluid is changed into kinetic energy of the fluid, which is then used in rotating the runner or rotor. So the Pelton turbine is an example for impulse turbine. Coming to the reaction turbine, the fluid entering the rotor, it has both kinetic energy and pressure energy. So the rotation of the runner is due to the impulse action, kinetic energy, and the change in pressure over rotor blades. So this is actually totally collectively called as the reaction force, because due to the impulse reaction and there is a change of pressure happening in the rotor blades. So this is reaction turbine, and Francis turbine, it is actually an example for reaction turbines. So depending on the head available, turbines are classified into following, namely the high head turbine. High head turbines, they vary in the range of 250 to 1800 meters, Pelton wheel being an example for it. Then there is called as medium head turbine, which is around the range of 50 to 250 meters, Francis turbine being the example for it. And low head turbine, which is less than 50 meters, Kaplan turbine being the example for it. Then according to pressure, it is divided as low, medium pressure, high pressure, very high pressure and super pressure turbines, where low pressure turbines have the range of 1.2 atmosphere to 2 atmosphere. Medium pressure turbines, they have up to 40 atmosphere range. High pressure turbines, they have up to above 40 atmosphere range, and very high, they have up to 170 atmosphere range, and super pressure turbines, they have up to 225 atmospheric range. And depending to specific speed also, you can term it as low specific speed, medium specific speed and high specific speed. Pressure generated turbines I have already mentioned. This is due to the pressure generated turbines and all. And according to the fluid used, they are classified into water turbine, gas turbine, steam turbine and wind turbine. So you can see the fluid used are water, gas, steam and wind. So let's move on to impulse and reaction turbines. I have already given a brief introduction of it, that is nothing but the tangential flow, hydraulic energy and rotation of the runner or rotor, and Pelton turbine being the example for it. And reaction turbines also, it has both kinetic and pressure energy, that's the reason it is called the reaction turbine. There is impulse action of the runner as well as the change in pressure in the rotor blades, Francis turbine being an example for that. So let's move on to the classification of engines. The classification of engines are mainly divided as internal combustion engines and external combustion engines. What are those types and all? I'll be explaining it briefly in the coming 4 slides. The internal combustion engines, they are divided into 2 types, namely the rotary and reciprocatory. The rotary engines, they are divided as open cycle gas turbine and Wankel engine. And reciprocating engine, they are divided as gasoline engine and diesel engine. In external combustion also you have two types, namely the rotary and reciprocating engines. The rotary engines, they are divided as closed cycle gas turbine and steam turbine, whereas the reciprocating engine is divided as steam engine and Stirling engine. So what are internal combustion engines? Let's go on to that. So internal combustion engines, it is a type of heat engine where the combustion of the fuel oil, it occurs with an oxidizer in a combustion chamber that is an integral part of the working fluid circuit. In the engine, the expansion of high temperature and high pressure gases produced by combustion applies direct force to some component of the engine. The force is applied typically to pistons, turbine, blades, rotor or a nozzle. So that is the parts of the engine. This force moves the component over a distance, transforming chemical energy into useful mechanical energy. The first commercial successful IC engine, it was created by Etienne Leonard around 1859. So let's move on to external combustion engines. It is a type of heat engine where the working fluid is contained internally and it is heated by combustion in an external source through engine wall or through the presence of an heat exchanger. So the fluid, it then gets expanded by action of mechanism of the engine and it produces motion or usable work. The fluid is then cooled, compressed and reused. That is nothing but the closed cycle turbines or the closed cycle engine, sorry for that. And cool fluid is pulled in. The working fluid in such turbines can be, in such engines can be of any composition and the system may be single phase or dual phase. Single phase means one state of matter. If solid, then it will be solid only. Dual phase means change of matter from liquid to solid. That is the fluid used. If it is used as solid, then it will be used as solid only. In dual phase engines, the fluid may be liquid, but when it comes out, it may be omitted out or expelled out as solid. So let's go into rotary engines. Rotary engines, they are type of heat engines usually designed with an odd number of cylinders per row in a radial configuration. Okay, they have something called as the stationary crankshaft and they have cylinders attached around them and they are very used in aviation purposes as they provide an efficient solution to the problems of power output, weight and reliability. The reciprocating engines, they are often known as piston engine because they use one or more reciprocating pistons to convert pressure into a rotating station. It was developed in Europe in 8th century. A fuel mixture is introduced inside the cylinder through the intake port, expanding the piston to the bottom of the cylinder. So compression process happens here in the reciprocating engine, and the ignition, it pushes the piston downwards, which provides useful work to the engine. The waste chemicals are output through the exhaust port. So let's move on to the classification of pumps. They are divided into positive displacement and dynamic. Positive displacement, it has two criteria, namely the rotating and reciprocating, where rotary is single rotor and multiple rotor and reciprocating is diaphragm and piston or flunger. In the dynamic, we have centrifugal or axial pumps. So what are positive displacement pumps? A positive displacement pump, it makes a fluid by trapping a fixed amount of volume or forcing the trapped volume into the discharge pump. Some positive displacement pumps, they use an expanding cavity on the suction side and decreasing cavity on the discharge side. The volume is constant in the given cycle of operation. So what cycle of operation is going on, according to that the volume will be constant. Moving on to rotary positive displacement pumps. These pumps move fluid using a rotating mechanism that creates a vacuum that captures and draws in the liquid. They are very efficient for the handling of highly viscous liquids. They have very slow and steady speed. That is the reason many erosions are coming on into the pumps, and they also decrease the efficiency of the pump. The reciprocating also, it has one or more oscillating elements. They are similar to the reciprocating engines. They help in the inward pressure of the plunger. They have higher velocity. They are used in common bicycle pumps. Let's go into dynamic pumps. They are type of velocity pumps in which kinetic energy is added to the fluid by increasing the flow velocity. This increasing energy is converted to a gain in potential energy or pressure when the velocity is reduced prior to or as the flow exists from the discharge pump. These pumps are generally low in efficiency than positive displacement pumps. However, they do operate at relatively high speeds and they have significantly lower maintenance requirements. So thank you guys. Please do rate this